Okay, so today we will talk about the Archimedes principle or also known as the buoyancy. So ano ba itong buoyancy? So buoyancy or also known as upthrust is an upward force exerted by a fluid that opposes the weight of an immersed object. Okay, so buoyancy is the reason kung bakit while you are in the swimming pool or when you are swimming on the beach, okay, so an object is much lighter. So you feel that an object is much lighter when it is immersed in the swimming pool compared to the object that is not immersed on the swimming pool. Okay, so I think you already feel this that when you are having an object, okay, when you are carrying an object, then uh, you will place it on the swimming pool. You can feel that the object is much lighter compared to the object that is not immersed on the water. It is because of the buoyant force, okay, a buoyant force that is opposing the weight of an immersed object in the fluid, okay, is because of the buoyant force that is opposing the weight of an object in the fluid. So that is the buoyancy. So how can we determine the buoyancy of a certain um, object? So using the equation for buoyancy, which is the force due to buoyancy or the buoyant force is equal to the density of the liquid, then multiplied by the gravity or acceleration due to gravity, then multiplied by the volume. Okay, so buoyant force is equal to the density of the liquid or liquid density multiplied by acceleration due to gravity, then multiplied by the volume of the object. So using this equation, we can be able to identify the buoyant force exerted by the water to the object. And one thing, we can also solve for the buoyant force exerted by the object using, okay, using the weight of an object while it is still not immersed in the water, and that is the true weight, okay? So ito yung true weight, that is the weight of an object while it is not yet immersed in the water and subtracted by the apparent weight. Okay, so when we say apparent weight, so this is the weight of the object while it is immersed in the water. Okay, so the buoyant force is equal to the true weight. So ito yung weight ng object habang hindi pa siya naka-immerse sa water or sa liquid or sa fluid, subtracted by the apparent weight. So ito yung weight ng object while it is immersed in the fluid. So true weight, hindi pa siya nakalagay sa fluid. Apparent weight, it is nakalagay na siya sa tubig or sa fluid. So buoyant force is equal to the true weight subtracted by the apparent weight. So using those two equations, okay, using those two equations, you can choose which among these two equations is appropriate to use in identifying the buoyant force of the water. Okay, so let's try to use this equation in a given problem. So a scented candle floating on an olive oil displaces a 0.0012 cubic meter of the oil. So what is the buoyant force exerted by the oil on the scented candle? Assuming that the density of an olive oil is 920 kilogram per cubic meter. So we have here, so meron na tayong isang candle, inilagay natin sa olive oil, and then yung olive oil nag-rise or nagtaas yung kanyang volume by 0.0012 cubic meter. So dahil tumaas yung volume ng tubig ng oil ng 0.0012 cubic meter, so therefore we can say that the scented candle has a volume of 0.0012 cubic meter since ito yung itinaas ng volume ng ating oil. And We also have the density of the olive oil, which is um, 920 kilogram per cubic meter. So ito yung density ng olive oil. So using this, we can be able to identify or solve for the buoyant force using the equation, okay, the first equation that we discussed. So F of B, or the buoyant force, is equal to the density. So the density is 920 kilogram per cubic meter. Acceleration due to gravity, which is 9.81 meters per second square, then multiplied by the volume, which is 0.0012 cubic meters. So substitute, okay? So cancel ang cubic meter. So 920 kilogram times 9.81 meters per second square times 0.0012, that is equal to 1.083024 Newton. And since the least number of significant figure we have is only 2, so we will round this to 2 significant figure, and that is equal to 1.1 Newton. So that is how to solve for the buoyant force, okay, buoyant force of an object using the density, the acceleration due to gravity, and the volume. Okay, so let's try to do another example. Okay, suppose the mass of your friend is 62 kilograms and he displaces 25.8 liter or 0.025 cubic meter when immersed in the swimming pool. So what is his apparent weight when immersed in the pool? So the density of a chlorine water is 993 kilogram per cubic meter. So meron tayong mass ng yung friend, which is 62 kilogram, and we also have the volume. So since he displaces 25.8 liter or 0.025 cubic meter, so therefore we can say that the volume is equal to 0.025 cubic meter. So we also have the density, or the density of the water, which is 993 kilogram per cubic meter. Okay? So, ang gagawin natin dito, hahanapin natin ano daw yung kanyang apparent weight. Okay, apparent weight. So, when you see apparent weight, ito yung weight ng object while it is immersed in the fluid. So, to do that, using buoyant force is equal to the true weight subtracted by the apparent weight, so we can be able to solve for its apparent weight. But before that, since our given is the mass, the volume, and the density, so we need to solve for its true weight and the buoyant force first before we can be able to identify or solve for its apparent weight. Okay. So let's solve first the buoyant force. So the buoyant force, using the density times gravity times volume. So substitute, the density is 993 kilogram per cubic meter. Then the gravity is 9.81 meters per square second. Then the volume is 0.025 cubic meter. So ito ang gagamitin natin since ito ang kapareha ng ating density. So cancel yung cubic meter. Then multiply these three, we can have a value of 243.53325 Newton. And that is our buoyant force. Then, solve natin yung weight niya since ang given is only the mass. So 62 kilogram is the mass of your friend. Multiplied natin by 9.81 meters per square second so that we can be able to solve for its weight, which is equal to 608.22 kilogram. Okay? And that is equal to, so force due to gravity, which is 608.22 Newton. So after natin ma-solve ang kanyang buoyant force and the true weight, so we can now be able to solve for the apparent weight. using buoyant force is equal to the true weight minus the apparent weight. So substitute natin to 243.53325 Newton, which is the buoyant force. So then equal to the true weight, so which is 608.22 Newton minus the apparent weight. So simplify natin ang ating equation. So apparent weight is equal to 608.22 Newton minus 243.5333325 Newton. So subtract natin silang dalawa, you can have a value of 364.68675 Newton. So since yung hinahanap natin is yung weight, so convert natin from Newton to weight. And that is equal to 364.68675 kilogram. And since the least number of significant figure we have is only 2, so round this to 2 significant figure, and that is equal to 360 kilogram. And that is how to solve for the buoyant force and the apparent weight or true weight of an object while it is immersed in the water and while it is not yet immersed in the water. Okay, so that is for the buoyant force. And that ends our discussion for today.